So I've made this video to help you understand types of solutions and how to solve the problems on the types of solution forms. Before we go through the questions, let's talk about the different types of solutions. There are 3 different scenarios. You can have one solution, no solutions, or infinite solutions. And each one of these looks different when you're solving your equations. When you have one solution, your variables will not eliminate, but you will be left with one answer, because with one solution, there is only one answer that will work. There's only one number you can substitute for your variable that will make sense for the equation. So for example, x might be 5. That's what it will look like when you solve the equation that has one solution. Now with no solutions, your variables will eliminate. And you will be left with something that doesn't make sense. For example, you might, after you've eliminated your variables, you might end up with something that says 8 equals 5. Well, we know that's not true. This is how you know there is no solution. There is no number that you can substitute for the variable that will make sense in your equation. That's because there's no solution. Now, the last one, infinite solutions. Again, for this one, your variables will eliminate. But this time, you will be left, once you solve the equation and your variables are eliminated, you will be left with something that does make sense. For example, maybe 5 equals 5. This is a true statement. This means you can substitute any number for the variable, and it will work in that equation. That means they're infinite solutions. There's more than one. It's either going to be one solution, any number will work with infinite solutions, or there are no solutions and nothing will work. Okay, so we're going to keep all of that in mind as we attack these problems. Let's start with number 2. Here I can see that we have parentheses on both sides, so I know that the first step is to distribute. So let's take care of that first. When I distribute the 2 on the left side of the equation, I get 4x minus 10 minus 8. On the right, when I distribute negative 2, I get negative 28 plus 6. And you know what? The question for this problem is simply asking you how many solutions are there going to be? How many solutions does this equation have? I don't need the answer. I just need to know how many solutions. And I can tell that my variables are not going to eliminate. They're different. When I subtract 4x, that's going to leave me with 2x. That's not eliminating. So I know, based simply on that the answer here is going to have to be one solution. Wasn't that easy? All I had to do is distribute, and I'm done. Because look, one solution, well, for no solution and infinite solutions, the variables have to eliminate. So if they don't eliminate, it must be one solution. Let's look at the third one. How many solutions does this equation have? Well, here, the first thing you're going to need to do, because there's no parentheses, is combine like terms. When I combine the x's, oops, let me go back. I'm going to combine my x's, negative 3x and 10x is 7x. I'm not even going to worry about this. I'm not even going to look at that right now, because I'm focusing on x. Here I have 5x plus 2x. That is 7x. Now look at what's happening. I can tell that these are going to eliminate because they're the same. They're the same. If I subtract 7x from one side, it's going to eliminate. So now, guess what? I do have to worry about those numbers because I need to keep going to see if I'm going to end up with the same number on both sides, which would be infinite, or different numbers, which would be no solution. When I combine 10 minus 7, I get 3. So on the left, I have 3 plus 7x. And I could rewrite that. That could say 7x plus 3. Anyway, on the right, I have negative 5 plus 8, which is also 3. So do you see how I have the exact same equation on both sides? Yep, right there, I can already tell it's going to be infinitely many solutions. But let me show you why. So if I subtract 7x from both sides, those eliminate, and now I can see I'm going to be left with 3 on both sides. This means infinite solutions. So that means my answer is here, infinitely many solutions. All right, which equations have no solution? So for this one, I know that my variables need to eliminate, and I have to be left with numbers that are not the same. So if I look at the first one, 8x plus 16, 8x minus 16. Well, I can already tell that my variables are going to eliminate. They're the same. And what am I left with? Positive 16 and negative 16. Those are not the same number, so that is no solution. For the next one, we have negative 3x minus 17, and on the right, you see that negative on the outside? I need to distribute that. That's a negative 1. So when I do that, I get negative 17 minus 3x. Again, these are the same. They're going to eliminate. When I add 3x to both sides, those are gone. And what am I left with? Negative 17 equals negative 17. That's a true statement. That's not no solution. That's infinitely many solutions. So that is not going to be part of our answer. For the next one, 9x plus 27 equals 27. There's only one variable term. Nothing's going to eliminate. I don't even have to solve it. It's going to be one solution. Oops. That one's going to be one solution. Now if I did solve it, and we can, that would be, I would subtract 27 from both sides. And that would be 9x equals 0. Now some people, don't be that person, some people get confused and they think that this means no solution. That is not true. No solution is only when both of the variables eliminate and you're left with imbalance, with a statement that doesn't make sense. From here, what you would do is divide both sides by 9, and you would find that your answer would be 0. The variable is 0, which makes sense because if you multiply 9 times 0, you have 0, which leaves you with 27 equals 27. So that would be one solution. Okay, last one. 2x on both sides. They're the same. I know that these are going to eliminate, so I'm going to cross the 2x's out, and look what I'm left with. Negative 6 and a positive 6. Those are not the same. That means it's no solution because the variables were eliminated and we're left with something that doesn't make sense. For number 5, we want to know which one of these are infinite solutions. So remember, infinite solutions, you're going to have variables that eliminate and you're going to be left with a true statement. So for the first one, I see I have to distribute that negative 2, and that's going to leave me with 3x minus 2x minus 20 is equal to x minus 20. When I combine like terms, I end up with x minus 20 on the left, and I have x minus 20 on the right. These are the same, right? So I can see that the x's are going to cancel out because they're the same on both sides, and I'm left with negative 20 equals negative 20, which is a true statement. They're the same, so I know that the first example is going to have infinite solutions. For the next example, again, we have parentheses, and I know that means I'm going to need to be distributing, so that's going to leave me with 5x plus 2x minus 6 is equal to 5x plus 6 minus 2x. Now, let's look at our variables. We need to combine like terms. That's going to give me 7x minus 6, and 5 minus 2, that's 3x plus 6. These variables are not going to eliminate because they're different. So I already know this will not have infinite solutions. The variables don't cancel, so that has to be a one solution. So that's not part of our answer. For our next example, I rewrote it just to show the fractions a little better. And I can see, well, first let's make common denominators, right? So I'm going to have to multiply this by 5 and that by 5. That way, we'll have a matching denominator, or a common denominator of 10. So that'll be 5x over 2 plus 1 equals 3x over 10, not 2. 3x over 10 plus 3. These are not the same. Therefore, they're not going to eliminate. Therefore, I know it is not going to be infinite solutions. This is another example of one solution. Okay, more fractions. So I wrote this up here just so I could see my fractions better. So First, we have to combine like terms. So there's nothing to combine on the left, so I'm going to leave that alone. Oops. Now I have 9/2 x minus 2x. Let's change this term so it has a common denominator of 2. 2 is the same as 4/2. So we're going to change that to minus 4/2 x minus 2. And now we can combine these like terms. Again, this doesn't change. What? It looks like a decimal. Sorry, 9/2 minus 4/2 is 5/2 x minus 2. Look what we have. We have the same equation on both sides. This 5/2 x on both sides, they're going to cancel out and be eliminated. And you will be left with -2 equals -2. So those are the same. I know that this means that they have infinite solutions, so this is another correct answer. Where was that one? Right here. That's another correct choice. Okay, so we have another one with a fraction. This one is actually going to be pretty easy. If you notice 7/2 x, well, that's already more than 1, right? That's like 3.5 plus another x, that's 4.5 x, 4.5 x's, and we only have one x on the right. So there's no way that these variables are going to eliminate. Therefore, it would only be one solution. So I wanted to rewrite this to show you something. The original problem was written as x over 2 plus 1 is equal to 3x over 10 plus 3. This is the same as 1/2 x plus 1, which is equal to 3/10 x plus 3. Those are the same. All right, let's make common denominators. I'm going to multiply these by 5, just like I did in that first problem. That's going to give me 5/10 x plus 1 is equal to 3/10 x plus 3. We can see pretty easily that these are not going to cancel out, are they? They are not the same. Therefore, this is one solution. So for number 5, there were only 2 right answers. Okay, these last 3 are very similar, and they go back to our original discussion of what one solution, no solution, and infinite solutions look like. So first, let's see what we're dealing with. So we have the equation 2 times the quantity 5x minus 4 is equal to ax plus b. All of these are the same, right? The beginning of them are the same. Did you notice? All right, so now this is where they differ. For the first one, it says find a value for a and a value for b so that the equation has one solution. So there's your key. This is what's different. We have one solution, no solution, and infinitely many solutions. Well, let's start by distributing that 2, because let's see what we're really dealing with. 2 times 5 is 10, so that's 10x, and 2 times -4 is -8. So that has to be equal to ax plus b. So this is where we're working. I know that with one solution, my variables cannot be the same because they can't cancel out. So that means for my answer, a can be any number except for 10. Because if it were 10, it would cancel that one out. That's not what we want for one solution. One solution means that my variables will not cancel out because I need that x to remain to figure out what the one solution is. So for a, it could be any number but not 10. I'm going to put 5. For b, again, it could be any number. For one solution, that part is immaterial, does not matter, so I'm going to make that 5 also. But I did go in and I hand graded all of these to make sure that it matched these criteria. So it's 2 points for each. For the next one, for 7, we want no solution. In this case, we need a to be exactly the same. These have to be the same because they need to eliminate to be no solution. So a has to be 10. Now this is the part that differs. The b has to be any number but not -8. Right? For no solution, we need b to be any number but not -8, because if it were -8 and your variables eliminate, then you would have the same number on both sides, and that's infinite. So b for this one, I'm going to write 6, but it can be any number as long as it's not -8. For the last one, infinitely many, we need the variables to eliminate, so again, the a has to be 10. right? Because you have a 10x on the left. If it's going to eliminate, you have to have a 10x on the right also. For infinitely many solutions, you have to be left with the same number on both sides. So in this case, we want b to be the same, so we would want b to be -8. For each of these last three, you got 2 points for each of your variables a and b. Okay, and if this doesn't make sense, go back to that first page at the beginning of the video and look at what one solution, no solution, and infinite solutions actually looks like. I hope that was helpful.